All right, let's talk about graphing a logarithmic function using transformations. There are two options. The first, if we want to graph f of x equals the log of x minus 2 in base 2, and then minus 3 outside of the logarithm. We cannot combine the minus 2 and the minus 3, by the way. So our first option is to ignore the transformations for a moment and compare the basic version of that to its inverse. Its inverse will have these 3 points on its graph. So we swap x and y, and those will give us 3 points that are on the basic version of what we're trying to graph. But we've got a minus 2 inside of the logarithm, which is going to shift things to the right 2 units, followed, the order matters, by subtracting 3. So if I take the original x values that I had, if I want to get the same y values here before the shifting down 3, then those x values now have to be the x minus 2 values. Shift all of those to the right, 1/2 goes to 2.5, 1 goes to 3, and 2 goes to 4. That way, if we plug in 2.5, 2.5 minus 2 is 1/2, and the log of 1/2 in base 2 is -1, because applying the definition, the answer to a logarithm is an exponent. That means that that base 2, 2 to the -1, will give you that 1/2. So we get this column. Same y values we had before, but then finally we have to shift down 3 units. So here I plotted the 2.5 comma -4, 3 comma -3, and 4 -2. When I connect, it looks like that. Now it would appear that we have a domain that is starting at, well, not equal to, but greater than 2, a range that is all real numbers, because it's going to keep on going up and up and up, even if slowly, and a vertical asymptote at x equals 2. We'll get to see precisely why that is when we apply option 2. Now, part of it is, for the domain, is we know that we have to take the logarithm of positive numbers. So if I take what was inside, x minus 2, set that greater than 0, then x must be greater than 2. There's our domain, range in set builder notation, and the equation of the vertical asymptote. Now let's take a look at option 2.